This is section 10.2, part 1. We're doing rational exponents, and the objectives we're doing today are just 1 and 2. We're going to use the definition of a to the 1 over n and use the definition of a to the m over n. Rational exponents, rational means fractions, so we're really talking about exponents that are fractions. And the fraction could be 1 over n, or it could be not a 1 on top, so m over n. It's much easier to do when it's a 1 over n, which we're going to find out right now, because we're going to do the definition of a to the 1 over n. It says if the nth root of a represents a real number and n is greater than 2 is an integer, then you can write a to the 1 over n equals the nth root of a. Okay, so that means whatever's on bottom of the fraction here of your exponent, that's what root you're taking. So let's look at how that works. Example 1 says use radical notation to rewrite each expression, simplify if possible. So if it says simplify, we're going to have to simplify it if possible. So I said whatever's on the bottom of the fraction on the exponent, that's what root we're taking. So in this one it's a 2, so we're going to take the square root of 64. Square root of 64 we know is 8. That's all we're doing. So that's simplifying there. On B, we've got the 3 on the bottom of the fraction, so that is the cube root of negative 125. Cube root of negative 125, we know from last section, is negative 5. C, we're doing the 5th root now, because 5's on the bottom of that fractional exponent. Now of this whole thing, 6x squared y. Now there's no 5th root of 6. There's no way to take 5 into an exponent of 2. We would need at least 5 to take a 5 out of that exponent, and the y doesn't have an exponent that's bigger than 5 either, 5 or bigger. So the only thing we can do is just leave it the way it is, so this one is done. Pause here, try your checkpoints. When you come back, I'll give you the answers. Alright, for checkpoint A, that equals 5, B is negative 2, and C is the 4th root of 5xy squared. Let's turn to the next page. Example 2. Now we're going to go in the opposite direction. It says rewrite with rational exponents. So now we've got the root formation, the radical formation I should say, and we got to rewrite it with rational exponents. That means put the fraction exponent there. And we don't have to simplify in this one. It doesn't say to. So we just got to rewrite it. And this is a 5 as our root, so that goes on bottom of the fraction for our rational exponent. So we got 13ab to the 1/5. 1 goes on top because there's no other power to deal with other than the root, which is 5. There will be in the next part where we change that 1 on top to something different. So let's move on to B. You've got xy squared over 17, and that's all raised to the 1/7, because 7 is our root right there. So that's all you got to do for A and for B. Pause here, try your checkpoints. When you come back, I'll give you the answer. Alright, checkpoint 2A is 5xy to the 1/4. Oh. Try that again. Much better. 5xy to the 1/4. B is a cubed b. Try that again. Got more room over here. I might as well use it. Equals a cubed b over 2. That whole thing is raised to the 1/5. Okay. Now, definition of a to the m over n. So now we don't have that 1 on top. We have a different number on top. That's what this is saying. And it gives you, it says if n to the nth root of a represents a real number and m over n is a positive rational number reduced to the lowest terms, and n is greater than 2 is an integer, greater than or equal to 2, sorry, then you get these two things. It says a to the m over n equals the nth root, so the bottom number is the root again, of a, and then you raise it to that power m. You can do it that way, so you can raise it to whatever this power is on top after, or you can raise it before you take the root. So a to the m over n equals the nth root of a to the m. It will work either way. Usually I do it the top way. But there are situations where it works better this way. So let's look at a couple of problems. Example 3. You got 1,000 to the 2/3. Okay, the bottom number is the root. So we've got the third root, or the cube root of 1,000. And I'm going to take and raise that squared, because I think it's easier to do it like this. Because usually if you square first, you're just making the number bigger, and it's harder to remember those numbers to take roots of them. But the cube root of 1,000 we know is 10 from last section. So we get 10 squared, which is 100. Let's look at B. The bottom number is 2, so we're taking the square root of 16, and then the top number is what we raise that to. So the square root of 16 we know is 4, so we got 4 cubed, which is 27. C. Bottom number is 5, so we got the fifth root of negative 32, and that's going to be raised to the third power. The fifth root of negative 32 is negative 2. And we're going to still have to raise that to the third power. That gives us negative 8. Oh. Okay. Pause here. Try your checkpoint. When you come back, I'll give you the answers. So checkpoint 3. The first one, the answer is 16 for A. B is 125, and C is negative 27. Let's turn to the next page. Example 4. We're going in the opposite direction now. You're going to rewrite with rational exponents. Means make a fractional exponent with it. We don't have to simplify again. So 3 is the root on this, so we got the cube root of 7 to the 5th. 3 is the root, and we're raising it to the 5th power. The root goes on bottom of the fraction, the 5th power goes on top, so what we get is 7 to the 5. Oh, I'll make a better 5. 7 to the 5 over 3. Okay, that's a power. Let me just do it over again so it doesn't look so bad. 7 to the 5/3. There we go. All right, B, we're going to have 4 is our root, so that goes on the bottom of the fraction. 9 is going to go on top. So we're going to have 13xy, all of that raised to the 9/4. Okay, try your checkpoints. Pause here, try them, and I'll come back and give you the answers. A should be, for checkpoint 4, is 6 to the 4/3. And B is 2xy to the 7/5. That's all for part 1. I will give you your assignment in class.